All right, so we're gonna go to the next video, which is 5.3, and that's dealing with vectors. So just reviewing vectors a little bit, and then steps in solving force problems. So sometimes vectors are not in just one direction, like left or right or up or down, but sometimes they are in multiple directions. So if it's in two directions, you'll need to follow these steps to find what are called the components of vectors. And then if the overall or resultant vector is in two dimensions, then you're going to have to use those components to figure out the hypotenuse, which is the size of the vector, and then theta, which is our angle or direction that the vector is headed. So so I'm going to do this part first here. And there's a couple quick practice ones. There's a practice vector sheet. These are on there. You can practice some more. The answers are also on D2L, but it's to get how to get components of vectors. So if we have a vector headed in a certain direction, so let's just say I draw a vector here, and I'll just have it going up and to the right. And this is a vector. It's got a size, so that size would be the extent of how long the vector is. So from this point to this point, that would be the size of the vector, and they would tell you that. And then the angle of the vector or the direction of the vector, they'll tell you usually with some angle, and usually we call that angle theta. So sometimes this is referred to as the resultant vector. So this might be this side would be r, and this would be angle theta, the heading. And it doesn't have to go up and to the right. It could go up and to the left or down to the left or down to the right, but I just drew it that way. And what we're going to try to figure out, we're going to try to find the components. So components, again, are the like parts of a vector, are the pieces of something that make it up. So we're going to try to figure out how far it goes in the x direction. Again, x is in the horizontal, so we're going to figure out how big the x component is, so how far it goes to the right. And then we're also going to need to know the y direction, which is how far it goes up or down. So we'll need to figure out how much it goes in that direction. So just for some notation purposes, this would be Rx here, the red side of that right triangle here. It's a right triangle. And Ry, or the y component, would be that's supposed to be a y. Fix that there. Ry, that's the green part of that vector. So so this vector is the overall is in black there, and then these red and green parts are the components. So to get the component of a vector, the x component would be the number, so whatever this r number is, times the cosine, cos is cosine on your calculator, and theta would be the angle. So we'll practice one down here in a second. And then similarly for the y component, for this green side of the triangle, we would do the size of r, the number for r, times the sine of the angle. One thing that you want to make sure your calculator is in degree mode. So when we get to the calculator part, I'll make sure my calculator is in degree mode. And that way I'll get the right values. Also, depending on your calculator, you might have to put it in a certain order. So like if you have a certain calculator, it might just be r cosine of the angle, and it's just how we would write it there, and r sine of the angle. But sometimes different calculators, they make you put the angle first and then cosine and then r. So if you're using like your iPhone, it makes you do it backwards. So I'll show you a quick one to make sure that you can check right away if it's in the right order or not. Okay, so we're going to practice this problem. So it says sketch the force vector and convert the following vectors into x and y components. So, and then we're not going to forget our signs. So, so this is 25 newtons at 30 degrees above the positive x. So this number here, this force or whatever it might be, for depending on if you're doing other vector math later, it'd be 25 newtons. That's r. So that this side would be 25. And then 30 degrees above the positive x, that's what this angle is. And I drew this on purpose, so I don't have to draw it again. This picture up here is the kind of similar to the picture that you would get. So that number is 25. And for theta here, it's 30. So that's 30 degrees. So what we're going to do is we're going to put that in our calculator. So I'm just going to write it out and try to type it. Okay. So it would be Rx, so the x component, and it would be, first off, in this picture, this component is going to the right, so I'm going to put a plus sign because it's going to the right, and right is our positive number, left would be our negative number if it was in the x, so it would be 25 cosine of 30 degrees. And you don't have to write out degrees, but just to make sure that you're in that mode. So I'm going to change to the Desmos, which is a scientific calculator, and I'm going to type in that value. So it's going to be 25, not 225, 25, and then the cosine button, and then 30 degrees. Okay. My answer showed up here. I'm in degree mode. So if I'm in degree mode, I should get that value. If it's in radian mode, it will be a different number. So those are really your two main modes, either radians or degrees. We work in degrees. So this answer is the right one. So 21.65 is just what I'm going to type in here for that answer. 21.65. It's positive. The positive means that it's going to the right. And it would be the same unit as the value here, which is 25 newtons. So it's 21.65 newtons. If you wanted to check to make sure you're doing it properly in your calculator and you're in degree mode, if you hit the sign of 0, you should get 0. And if you get, whoops, hear that. And if you did the cosine of 0, you should get 1. All right. Those are always what it should be. If for some reason your calculator is giving you something weird that isn't those answers, that's like the quickest way, one of those two, to verify that it's in degree mode. You can probably Google your calculator type and how to fix it, or just send me a message and a picture of your calculator, and I can tell you how to make sure you're in the right mode as well. So just, ask if you need help or if something's showing up weird, just ask and I'll help you out with that. Okay. So we're going to do similar work for RY. So RY would be the R value, which is 25, the length of that resultant vector, and the sine of 38 degrees this time. And our picture, according to our picture, this arrow is going up. So it's going right, which is positive. It's also going up, which is positive. So I'm going to put a plus sign there. And that's going to help me remember that it's going in the upward direction. So it'd be 25 sine of 30. And it's still degrees. So make sure you're in the degree mode. I'm going to go back to the online calculator. I'm going to type in 25 and then the sign, and then it's 30 degrees. And that's 12.5. So that's going to be the answer for that. Again, if you're in radian mode, so if I switch this to radian mode, you get a totally different answer. That's weird. So that's that. So 12.5 is the right answer. So 12.5 newtons, and it's still positive. So those are the two pieces. If you wanted to check, another way you can check to make sure you're in the right mode, if you do the Pythagorean theorem with that, 12.5 squared plus 21.65 squared square rooted, you should get 25. If you don't get that, whoops. If you don't get that, you've gotten some wrong values, and that's not good. So that's the first one. So that's like how to figure out the components of a vector. You do that when you're first adding forces together. We'll get into that in a second. If you have something in 2 dimensions. And then the next one is like once you're at the final step and you've gotten everything put together, if you have 2 dimensions, you have to use these steps over here to figure out this resultant vector. So this one says convert the following x and y components. So these are my components. It's like rx and ry. And we're going to take it and we're going to find the resultant and the direction. So we're going to use these two. So again, drawing a picture just to make it make more sense. It's going 3.4 to the right. So I'll be consistent with my color. So it's not what I want to do. So there we go. So we'll call the x direction. And then for the y direction, it's going up, and it's a little bit shorter. So maybe that's 2.7 comparatively. And we are looking for the overall resultant. So we're looking for R this time. We're looking for R. We know this side is 3.4. And the other side here is 2.7. So we're going to look for R. We're going to solve for how big of a vector do we have? That seems to be a question mark. There we go. Now we're also going to solve for theta. So this angle theta. The first thing we're going to do is solve for R. And to do that, you just use the Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. I have a typo here. Let me fix that. There we go. Component, not competent, or whatever that word is. There we go. Component. So it's x squared plus y squared equals basically r squared. So I'm going to write that out here. So I'll just say like x squared plus y squared equals r squared. So x is 3.4. And I got to square that. Plus y, which is 2.7. If these happen to be negative, it's fine. They would get squared away and made positive by the squares. So that's fine. And then we got r squared, which is what we're looking for. We're not actually looking for r squared, we're looking for r. So we're going to have to do a little bit of math at the end. But let me jump back to Desmos and put this in. So it would be 3.4. Clear that out. So 3.4 squared. And then I'm going to add, what was it, 2.7? Yep, 2.7. Going back here. Let's square that. And that got me 18.85. So I'm going to come back to here and say this is 18.85. And that's equal to r squared. We don't want r squared, we just want r. So in order to get rid of a square, you take what's called a square root on both sides. So we're going to hit this button to take the square root. So when I hit the square root button of the answer, which is 18.85, I get 4.34. And that is a perfectly good number. If you remember your geometry a little bit and triangles, the hypotenuse of a triangle should be the longest of the sides. So we got 4.34. If this was a force vector, which is what I'm talking about here, it would be newtons for the unit. And 4.34 is bigger than 3.4 or 2.7. So that seems good. So that seems to check out. The last part of this, so we found the size of the vector. Remember, vectors have two components. They have the size part, which we just did. We also have to find the direction. So the direction is theta. So that's what we're looking for here is theta. So we're going to use the calculator again to do this, and I'll show you how. So to get theta, it says, and I skipped over it, so I'll scroll back up. If we're looking for theta, that's the symbol for theta. You're going to do the inverse tan of y, the y component divided by the x component. And then we're also going to look at kind of which way it's headed and describe how it's going. So the inverse tan or second tan button, it's really the arctan is the correct mathematical way to say it. But in physics, we're not really worried about the mathematical terminology, but it's tan to the -1 power is what it looks like on your calculator. If you're looking on your calculator, it'll be like shift or second and then the tan button. So whoops, it's the inverse tan, and then it'll be in parentheses. So you'll have a parentheses here, and you're going to divide the y component, which is our 2.7, by our x component. So we're going to put the x component in the bottom, which is 3.4. So again, you're not going to do that in your head. You're going to use the calculator. So let's go to the calculator. And let's go ahead and clear again. So it's going to be, I'm going to hit function, and I want tan to the -1. That's the arctan. And then we're going to get back to the number. So we said it was 2.7 divided by 3.4. You could use other trig functions to get this answer. That's fine. But that's what we got. So it's 38.45. So theta, our angle theta, is 38. I think that's 4.5. Yeah. So we'll just round it to 38.5. And that's degrees. Again, you want to be in degree mode in your calculator, and that'll be okay. So let's just talk about what that means, and we have to describe it. So that's what the description is. We're going to say where this angle is going. So 38.5, just to make sure it makes sense. If you look at these sides, the red side and the green side is bigger than the green side. So if they were equal, it would be what's called an isosceles triangle, where the two sides, the two legs of the triangle are equal in length. So that would be a 45, 45, 90 triangle. So this angle would be 45 degrees if they were the same. If the angle here, if the y component is smaller than 45, which this number is, then this y side, the 2.7 side, should be less than the x side. So that's like a way you can check. If it's bigger than 45, so if it was like a 60-degree angle or something like that, the y side would be larger than the x side. So that's just a way to check. So 38.5 seems reasonable, and now we have to describe where it's headed. So the way that I recommend people do this is you describe it with a sentence, and like you look at your x and y axis. So again, that's the x axis, that's the positive x, that's the positive y. And we always start on the x axis and we go up or down. So if you go up, that's above. So we're starting on this positive x and we're going up. So this is going to be called above and then whatever axis you go above to get to that point is going to be the right axis. So it's above the positive x-axis. Just to practice a couple more of these, just to make sure it makes sense. You just find your angle, and you're not going to have to do this very often, but just to make sure I'm explaining it in a way that makes sense. So let's say we had a vector that went that way, and we wanted to describe the angle here between the arrow, the black arrow there, and then the x-axis, the horizontal axis. So for this one, give you a second to kind of try to think about how would you describe that. I would say you're going down, so that's below. So you're the horizontal, that's the x-axis, you go down to get to the end of this arrow. And it's below the negative x-axis. Right? So that's where this is. So this theta, this angle theta would be measured, whatever angle this is, whatever number it would turn out to be from your inverse tan function, and it would be below the negative x. Okay, so so we're good with kind of reviewing vectors, and then the next part is to get into how do we solve these problems. And I'm going to go into more detail next video with this, but these are sort of the steps. So step one, you're going to draw your free body diagram. We've done that fine. We're going to make an XY chart. We've done some of that as well. So we've figured out kind of if it's going right or left or up or down. And then if it's not going in that direction, it's a 0. We did this with simple situations. We'll do it with more complicated ones coming up. We're going to find our values for specific forces. If they're not given, we're going to use the gravity equation or the friction equation if we know the information, and fill that stuff in. If there's a force at an angle, we're going to use the cosine and sine to get the x and y components. That's what we just primarily went over in this video. And then we're going to solve for missing boxes in the chart. So again, you'll see this process played out in the next couple of videos of me practicing some numbers, but you're going to solve for missing boxes. You're going to do some algebra, and then you're going to use like total up the columns to get the net force. And then you're going to use Newton's second law. The net force is equal to mass times acceleration, and generally solve for the acceleration. So that's the procedure. We'll get into these force problem practice 1 and 2 on the next video, and then 3 and 4 in the last video for the week. And I will be seeing you shortly. Have a good one.